So putting together equations and inequalities involving absolute value, I want to summarize that and just run through some examples to really help us settle in concretely. So whenever you're dealing with an equation that's involving an absolute value of a quantity that's got a variable, what the meaning of that is it's saying that the distance of my x from 0 is going to have to be worth whatever number this is over here, which in this case is denoted as the number a. So what that ultimately means then is that that x, or whatever's inside the absolute value, has to be equal to a itself or to the opposite of it, so that you get a distance of exactly a from 0. So that right there is equivalent to what we're seeing right here. Okay. Then in the other cases of inequalities, so whenever the absolute value is less than, or if you had a less than or equal to, what the meaning of that is that the distance of x from 0 has to be less than a. So it needs to be within a certain distance from 0. So this statement right here is equivalent to saying that x could go as far away as a, but has to stay under it, so it stays closer to 0. But then it could go down to as low as negative a, but can't go anywhere below that. So this statement right here and this statement right here, they're equivalent. They're saying exactly the same thing as each other. So if this was a less than or equal to, then of course that would just mean that you could write the statement like this if you had those symbols instead. Okay. And then finally, last of all, when you've got an absolute value quantity that's isolated and you know that it's greater than some particular number a, then you need to be more than that many units, a units away from 0. So you have to be at least as far as a and farther to the right, or conversely you could be at negative a and then lower. So this statement right here is equivalent to an or component inequality, that you need to be having the x be lower than the negative a, and then you have to write the word or x is going to be greater than a. And then of course if you had that symbol that was involving the equal to part as well, then you can incorporate that into the or component inequality also. Alright, so some examples of solving that involves different equations and inequalities. So it's to solve each equation or inequality, graph the solutions. So with the first one right here, we don't have an absolute value isolated. You're going to need to do that first always. So we just need to undo the subtraction of 5 to isolate this absolute value quantity. So you're going to then end up with this once it's isolated. So now you have an absolute value quantity that is going to be less than or equal to 22. So the meaning of this is that the distance of 3m minus 4 has to be less than 22 from 0. So you could go as far as 22, but then as low as negative 22, and you need to be within that interval of numbers so that you're less than 22 from 0. So 3m minus 4 is going to go right there. And then you just can solve from there, add 4 to everything. And then divide by 3, and you end up getting that solution set right there. So the graph of the solution set would just basically look like this, so that if you'd had negative 6 there and 26 thirds right there, then your solution set would be all of these numbers right there, and then you could put in filled in dots, since you could include negative 6 and 26 thirds in the solution set there. Then in the second example, I guess we've got to isolate the absolute value first. So we're going to have to, I guess, subtract the 3 first from everything. It's going to give you 1/2 times the absolute value of 3j is greater than 6. And then we can go ahead and multiply this side by 2, so that we multiply by the reciprocal of 1/2. And then that's going to then give us the absolute value of 3ga alone. Because we multiplied by a positive, the symbol still is the same direction, and then it's 12. So now in this case, because we've got a greater than, or the absolute value is greater than a particular number, then you've got to be more than 12 from 0. So that implies that from negative 12, that means that the 3j has to be underneath that negative 12 to be more than 12 from 0, or greater than the 12. So this greater than statement implies an or component equality. And then you can just divide everything by 3 on both sides. Does not flip any inequality symbols. So then, I wrote the same thing there. There we go. So j is either under -4 or j is greater than 4. So on a number line, that basically just looks like this, is that you'd have kind of two disjointed solution sets. There should be open circles, though. And that would be your solution set there. And then the last example right here, this is an example of an equation. We want to isolate the absolute value, so we're going to have to add 10 first of all, and that's going to give you the absolute value of 4 minus w is equal to 11. So now, if we want it to just be equal to, we need to be exactly a distance of 11 from 0. So in order for us to be exactly a distance of 11 from 0, then that means that this 4 minus w either needs to have a value that's -11 or 11 for this to come out to just be a true equal. So we can set up that 4 minus w has to equal -11, or that 4 minus w has to equal 11, and then solve, subtract 4, same thing here, and then divide by -1 on both sides. So it turns out that those two numbers and those two numbers only are going to be the solutions. So what that would look like on a number line then is that if this were where 15 was and this was -7, just that dot and that dot, so just two numbers alone are the solutions to that equation.